Hey guys, today we're going to talk about something called polar coordinates. And this is just another way to graph a point. And what we're going to use now is instead of like x and y, we're going to use an angle and a length. So we can graph based on an angle and a length. Very similar to when we did vectors, a magnitude and an angle. So you're going to see it's going to be very similar. Now, what you in the past you might have seen some type of paper. It's called polar graph paper. We will use this in class, and it's like a bunch of circles and has like angles already marked on it. And we don't need it for what we're doing because what we're doing is pretty straightforward. So we can just kind of like make it wrong. We're just going to base it on our regular xy. Okay, so let's take a look at our regular xy. And now, so this was x and y, just regular coordinate system. So now we're going to change it. So now this x right here is going to be the polar axis. This is where we're going to start. We're going to start at 0 degrees. That's where we're starting. And the origin is now called the pole. And what we're going to do is we're going to go up some angle, some theta, and we're going to go out some distance, some length. And this is going to be our point over here. So it's called P for point. And this length is going to be called R. And when we start graphing, that R is like going to be like a radius, but it's really a distance, but it's kind of like a radius if you want to think of it something like that. So we have some things here. So we have the theta, and that was called angle direction with the vectors. Now it's going to be called the directed angle. And we have R, and R is going to be called the directed distance. And the R is the magnitude. It's like the magnitude. And it's not exactly magnitude because as we're going to see, sometimes the R could be negative, where when we do magnitude, it's always positive. So let's just take a look. Let's start. All right, so if I asked you to graph 5 comma 30 degrees, all right, so now you're like, well, it looks a little bit like a regular point, except let's take a look up here at this P. If we had the P value, this R would be in front. That goes in the front. That's the length, the distance, and the theta is telling you what angle to go at. So it's going to be called R theta. So when I give you a point, 530, we're going to look at it. We're going to go 30 degrees, and you're just going to guess when we're doing it by hand. So like let's say like this is 30. So this would be 30, and this whatever distance 5 is. And that's why when we use the circle paper, you'll see the circle graphs. You count out each line is worth 1, and it has a bunch of angles on it, so you can tell. And so my point is right here. That point would be 530. Let's try it again. What if I said graph 2 comma 110? 2 comma 110. Okay. So we make an axis. 110 is the second quadrant, and that's 90, so it's a little bit past, something like this. And let me just undo that. I make that like dotted line like this. And so it's along this line because this is 110. And you'd measure, well, now look, if I did the other one, that's 5. That's a little far. So maybe 2 is right here. So I'll call that one 2 110. Now, we can do all different types of things. So like we can have negative R's and we can have negative angles. Our angles might be in radians. Why don't we try that? So why don't we try one with radians, maybe a negative angle. Okay, so let's do some radians. So if I say 3 comma negative pi over 9, and as soon as you see that, you should recognize pi is radians. And what we want to do is get rid of the pi. So what you should know is pi equals 180, or pi radians equals 180 degrees. So we're going to get rid of this pi. So we negative 180 over 9. So you should know this is 3 negative 20. Now, when we graph negative 20, instead of going up, we go down, just like we used to graph. So this would be something like this. It would be negative 20 degrees. And 3 units, whatever 3 units are, 1, 2, whatever 3 units are. And so this point would be 3 comma negative 20. We can go, we can do negative distance. The r value could be negative. So for example, if I say negative 2 comma 30, okay, just do like an easy one. Okay, so let's think about this. So 30 degrees, so I need my angle. So 30 degrees is something like this. That's 30 degrees. Okay, that's true. Now if I went forward, this would be positive 2. That'd be positive 2. But I don't want positive 2. So what I got to do is I got to continue this line through the origin, which is called the pole, and I have to go backwards 2. So this point down here would be negative 2, 30. Now, a thing to remember is this. If this was 30, this angle off the x-axis is going to be 30 also. So, like, you can find that angle. And actually, we will use that angle because we can call a point several different ways. So let's try another one. Let's do another one. So for example, one more and then we'll move on. So how about negative 4, negative 3 pi over 4. Okay, so it's like triple whammy. Negative distance, negative angle, angles and radians. So first thing is I want to get this to normal. So this is pi is 180, and mess around with that. And hopefully you can know it's negative 135. And what we're going to do is I'm going to graph. Now look, so what I do is I'm going to graph the angle 135. So it's going down, it's going this way. So that's 90. So it would be something like this, right? So this from here to here is negative 135. Now, if I said positive 4, I would move out 4 spaces. So this point down here would be 4 negative 135. But since it says negative 4, I have to go back. So I'm going to continue this line. And I'm going to go 4 spaces, whatever that is, whatever unit you count by. This point here would be negative 4, negative 135. And so what we can do is we can write a polar coordinate several different ways because there's different ways to get to the spot. So we can write polar coordinates in 4 different ways. So, for example, let's do 530. Do an easy one. I think that's one of the first ones we did. All right, so 530. So 30 degrees. And 5 units. 1, 2, 3, 4, 5. So let's say it's right there. That's 530. Let's call it point A. Well, that's 530. I agree with that. Well, you know what? I could have graphed it using a negative angle. So when you do a point, you're going to have 2 with a positive 5, and you're going to have 2 with a negative 5. And you got to bang around with the angles a little bit. So, ready? If this was 30, if I want the negative angle, I got to go negative 330. All right. So now how would I do negative 5? Well, that would mean this. That would mean that this line, the angle, it would have been, if this was a negative 5 over here, it would make it fall to this one. Okay, well, if that's 30 degrees there, that means this is 30. And what I'm going to do is I'm going to go from here to here. So that's the positive angle. So it'll be a negative distance with a positive angle. And if that's 180, that means that was 210. So negative 5, 210. And then finally, I could have done the negative angle this way. And so that would be negative 5 with negative 150. And so the last thing we're going to do, and it's just going to take a couple minutes, is converting these things. So let's do an easy one. We'll do an easy one. All right. So let's say I have, so we're going to convert rectangular, which is your normal x and y, to polar, and vice versa. And the polar coordinates, if you recall, is r comma theta. All right. So let's say I have a point negative 1, 1. All right. So the first thing is I want to do is I want to graph negative 1, 1. There's my point, negative 1, 1. So far, so good. Now, what I need is I need an angle and I need a distance. Well, the distance is like the magnitude, so very similar. What we did is I'm going to make a little triangle and I'm going to find this angle. And I'm just going to call this angle A for now. And so what I'm going to do is I'm going to go tanth A equals 1 over 1. And I'm not putting pluses and minuses because the angle, I'm gonna drop it in the right quadrant, just like you did in trig. So I go second tan negative 1 of 1 over 1, and use your calculator, or you might know this, 45 degrees. And so 1, 1, and I need to do Pythagorean theorem, and I know that this is rad 2. Now, if this was a vector, this rad 2 would have been called the magnitude. But since we're doing polar coordinates, this rad 2 is called the r value. Okay, so now I got the r value. Oops, it is. So now I got r value is rad 2, comma. Now, if this angle is 45, right, so let's think about this. If the angle is 45, I want this angle because that's my theta. So that makes 135. So this, in polar coordinates, negative 1, 1 is rad 2, comma 135. Now, we can go the other way. And if you remember, when we did vectors, when we did the vectors, we had a formula, and it said something like this: magnitude of v times cosine theta, and the magnitude of v sine theta. And that's how we could figure out a vector. Well, it's very similar for this. X is r cosine theta, and y is r sine theta. And so we're just going to plug in the values. Okay, so I got x equals r, which is rad 2, times cosine 135. And we got y equals rad 2 sine 135. And what you need to remember is that x is cosine, y is sine. And now what you do is just type this in a calculator, and you get negative 1. Type this in a calculator, positive 1. So if I convert backwards, I get the point negative 1, 1. And that's it. So in class on Monday, we're going to expand on this, on doing all these types of things. All right? Have a nice night.